So, who's there in the class? Let's. Hiba, how are you?
I'm fine, sir. How about you?
I'm fine as well. Thank you so much for asking. Okay, so let's wait for 1 to 2 minutes that Adil and Abdullah are still not there. Let's wait 1 2 minutes more. So, how many of you have done the revisions of the previous 4 topics that we have covered so far? Electric charge, potential difference, electric current, and Ohm's law. Yes, everybody. How many of you have done that revision?
Yes,
Shweta did. Very
Yes.
good. What about rest?
Yes, sir.
Very good. Samina, I think you have missed the last class of Ohm's law and electric current.
Yes, sir.
Okay, okay. So what about the potential difference in electric charge? Have you done the revision?
Kind of, sir.
No.
No, kind of, sir.
Acha, kind of. Okay, okay, okay. Chalo, koi nahi, koi nahi. Next. So let's start the class like it's already. Okay. So basically, in the last class we've started the Ohm's law. So Ohm's law is basically the law which basically establishes the relation between electric current and the potential difference. So basically, this law states that electric current in a circuit is directly proportional to the potential difference across its end at constant temperature. So why constant temperature? Because in the next topic, what we are covering, in this class itself, we will be doing the factors affecting the resistance, which basically involves the temperature as well. If you increase the temperature, your resistance will also increase. It has an effect on the resistance if you increase the temperature. So that's why in this law, this specific word should be used when you write the Ohm's law statement. Clear, everybody? Whenever you write Ohm's law, you have to use constant temperature word. If you don't use that, your marks will be deducted. Definitely deducted. Clear?
Yes, sir.
And resistance is the property of a substance which opposes the flow of current. Clear?
Yes, sir.
Yes.
Got it? Okay. So let's do some questions based on that. Can anybody tell me what is the SI unit of resistance?
Can you repeat?
And I'm asking that what is the SI unit of resistance?
Ohm, sir.
Ohm.
Ohms. Very good. Ohm. OHM, ohm. Clear, everybody? And the sign of that ohm is omega. That word is called omega. Solve this question, everybody. Straightforward question. Good evening, Abdullah. Do this question, Abdullah.
Three answers. Three.
Okay, Shweta said 3. What about rest? Yes, who said the answer right now?
Samina.
Samina.
Yes, sir.
What's your answer, Samina? 4.
No, sir. 3.
3. Samina also
3.
said 3. Karishma said 3. What about Hiba and Abdullah? 3. Okay. What about Hiba?
3, sir.
3. Very good. The correct answer is 3. So basically, this statement is a little bit, you can say, confusing, which makes it you can say little tricky. Is saying that number of coulombs passing through the resistor per second. It's nothing but number of coulombs passing through the resistor is nothing but current. Yes or no? Q by T.
Yes.
Sir.
That's what the current is, na? The definition of current is that the number of coulombs passing through the passing through unit time. Clear?
Yes, sir.
Okay. So let's come to the point here. Basically, we have to do the, you can say, the graph of the Ohm's law as well. So I think no, I didn't basically started the graph part. So graphical representation of Ohm's law, about basically graphical representation of Ohm's law. So graphical representation of Ohm's law. So first, okay. So let me take this. Let's suppose that on the y-axis I'm taking. Just a second, let me share my screen again to you. So here is this. On the y-axis basically. So basically, just a second. Yeah. So on the y-axis, you are taking, in this case, you are taking the 1 by v, oh sorry, I as the y-axis and v as the x-axis. Clear, everybody? And in this case, you are taking v as the x-axis, y-axis, and I is the x-axis. Clear? So this will also straight line. So basically, let's see what are the differences between these two graphs. Clear? So basically now, so everybody tell me, if you how many of you know the slope word in the graphs?
Yes, sir.
Okay, Hiba knows that word. What about rest? Samina, Abdullah, and Shweta and Kaishwa?
No, sir.
Yeah, no.
I don't know, sir.
Okay, no issues. Basically, when you take the ratio of y-axis to the ratio of x-axis, the value comes out, that ratio is called as slope. Slope is the y-axis upon x-axis. Clear? That is called as slope. Clear? Yes or no, everybody?
Yes.
Is that clear now?
Yes.
When you
Yes,
take
sir.
the ratio of y-axis to the x-axis, that ratio is called slope of the graph. And your slope, okay, everybody, in that case, just what is on the x-axis? What is on the x-axis?
V.
Volt.
V. What is on the y-axis?
I.
I. Very good. So now tell me, just taking the Ohm's law, V is equals to IR. Okay. And if the value of R is V by I, just reciprocate them. What will it become? It would be 1 by R equals to I by V. Clear?
Yes.
Yes or no? So now here I by V is the value comes out to be in this graph. Clear?
Yes.
Yes.
Huh? Any doubt?
No, sir.
Okay. So that value will be equals to 1 by R. It means that the slope of this graph is giving you the reciprocal of resistance. Clear? When the value of I is taken on y-axis and the value of x is taken on the voltage is taken on x-axis. Clear? And
Okay,
it says that now tell me, everybody, the question, basically the statement of the Ohm's law says that current is directly proportional to the voltage potential difference across it. Clear? Now see that thing. At every point, if your current is increasing, your voltage, your potential difference is also increasing. Yes or no, everybody? It means that straight line will be the graph of the Ohm's law. You can see now, at every increase in point in current, your voltage difference is also increasing directly proportional. Clear?
Yes, sir.
Any doubt?
No, sir.
Sure?
Yes, sir.
Yes, sir.
Okay. Just a second. And in the same way, now tell me everybody, slope is here slope is equals to your what is on y by x?
V.
V. What is on x-axis?
I.
I. What is basically V by I? What is V by I? You by Ohm's law.
Yes, sir.
Everybody, V by I is R, resistance. Yes, correct, resistance. It's R. Clear? Now, if the value of, so you have in the some of the questions, basically the graphs like the current is on the y-axis and the voltage is on the x-axis. So both the graphs are right. There is no basically not nothing wrong with these graphs. So some of the students say sometimes because they usually takes V on y-axis and I on x-axis. This is the common graph, but sometimes the board's exams gives you this example as with this you can say graph as well. So sometimes students gets confused. Clear? In this graph you will get the reciprocal of resistance, but in this graph you will get the value of exact resistance. Clear?
Yes, sir.
Yes.
Any doubt?
No, sir.
Okay, so in this example itself, when you increase the voltage, current will also increase. Yes or no? This is also nothing but Ohm's law. Directly
Yes.
proportional, or both the things are directly proportional to each other. Clear?
Yes, sir.
Sure?
Yes, sir.
Yes, sir.
Very good.
Yes.
Very good. Very good. So basically, these are the questions, but not basically not questions, specifically the just a second. Let me take some of the questions if it's question any. Hmm. There's like such no such questions as there. Uh, just okay, one question I got it. So I will give you 2 minutes. You can basically try to solve this and then let me know because it's a straightforward. So I want that you should solve this first. Clear? You have to find the value of V by I ratio when the potential difference is 0.8. Potential difference is on the y-axis and the current is on the x-axis. Clear, everybody? Solve this. Just apply the Ohm's law.
2.5.
Solve this. And like, what are you saying? Karishma, you are saying something?
No, sir.
No, sir.
Samina.
Samina, yes, Samina, what are you saying, dear?
Sir, I got 2.5.
2.5. Solve the other values. All the values are same.
Oh, no, sir. I mean, I have to check.
Check it.
Yes, sir. All the values are same.
Okay, so Samina said all the values are same. What about rest? Hello, Afra, how are you? Like, dear, when you joined the class, dear, like I didn't get any notification about your joining. How are you,
I
dear?
joined. Good. I'm good, sir.
Okay. You've joined just now? Yeah, you were in like in the class since starting
I joined 10 minutes before.
10 minutes before. Okay, so I think you have okay, dear, no issues. So have you like covered the part of graphical representation of Ohm's law? The I've
No,
just
sir. I couldn't attend few classes.
okay. So you didn't cover this in the class right now.
Yes, sir. Because when I joined, you already had the question on.
Okay. So I think you must have joined just 5 minutes because it's
Oh.
it's in the yeah. Okay, no issues, dear. No issues. I will talk to you in the later part of the class. In the last class, so we were very short of time. No worries. Okay.
Okay, sir.
Yeah. Any answer? Anybody? Okay. So
Sir, it will be 2.67, not 2.25.
2.67.
Yes, sir. I checked it out.
Okay. चलो ठीक है. Okay. करिए. Okay. No issues. Okay, so everybody look at the point here. Just what you have to do first, you have to do nothing but it's asking at point 8. Clear? Point 8 will be somewhat here. Yes or no? Yes or no, everybody, at least yes or no.
Yes.
Yes, sir.
Now, just a second. So point 8 will be somewhat here. The potential difference is 0.8. So actually drawing नहीं हो रही है इससे, sorry. Okay, चलो directly मैं ऐसे ही लिख देता हूँ because a little bit. So your V is first in the first case. the first case, your V comes out to be 0.8 volt. Clear? And your currents comes out to be, you have to find the current just which is corresponding to the 0.8 voltage. Clear, everybody? I'm audible?
Yes, sir.
Yes, sir.
So now tell me what will be the current?
0.3.
0.3. Samina, your voice is cracking a little bit.
0.3.
0.3.
Yes, sir.
Okay, so you are saying 0.3. Okay, got it. So yours, the answer was like basically you said 2.5 na?
No, sir. 2.67.
2.67. What about the rest? Hiba, you said 2.5? 2.4. 2.4 na? 2.5. So basically, Karishma and Hiba, if your value is the basically the resistance will be equals to 2.5 in this case. How? First 1.6, let's match the 1.6 because we can 1.6 will be here. And next is 1.2. So it would be like around this. थोड़ा सा actually ये थोड़ा सा इसमें जो ना sorry for the like it's a little bit tilted. So in second case, your V is 1.2 and your currents comes out to be 0.5. I is equals to 0.5 ampere. Okay. And in third case, your currents, the potential difference is 1.6 and your currents comes out to be I is equals to 0.6. Clear? First do this, V by I will be equals to 1.6 divided by 0.6. Clear? So 16 by 6. Decimal will go on. Clear? So it would be equals to 6 to the 12, or you can, or 3 by 8 by 3. So 8 by 3 will be equals to 3 to 2.6 something. So okay, 3 to yes 2.6 something. And here 1 point V by I will be equals to 1.2 divided by 0.5. It is 12 by 5. So it comes out to be 2.4. Clear? And your V here is, what is the value of I? I is around 0.8, 0.3. V is equal, I is equals to 0.3 ampere. So V by I is equals to V is 0.8, 0.3 is equals to 8 by 3, which comes out to be 2.6. So if you take the average of this, just a second, so it would be 2.6 into 2 plus 2.4 divided by 3. So the average comes out to be 2.5. So basically, your average your resistance will be equals to 2.5 ohm. Clear? Hai? Everybody, is that clear to you? Yes or no? So this will be the question, single question, rather, like there is no such question on this topic, graphical representation. Only a single question can be there, which will like this. Or आपको, it may be a question like this. You may be given the values of the V and I, and you have to plot a graph. So nothing but you have just not like suppose that like this is a x-axis and some values are given. So it will be like this. So straight line will be formed. Clear? Like this. Clear? Straight line will be formed when you plot the graph of Ohm's law. Clear, everybody?
Yes, sir.
Yeah.
Yes.
So that's all for this Ohm's law. Let's start the factors affecting the resistance. Factors affecting the resistance of a conductor. Or okay. So resistance is a physical property of a material. Clear? So it will be like it will have some you can say factors which by which it will affect. Like if you increase something, it will also affect. Like human body, if you increase the temperature of human body will not survive. Yes or no? Some factors affects our body. Like if in the extreme cold, our body like that factor also affects our body. Yes or no? Everybody?
Yes,
Yes,
sir.
sir.
Yeah. And if you basically or you can say if you call like somebody like sometimes happen that some of the human beings fell ill. So after that they are not able to recover it well. So that also affects our body, the immune system. So same thing with the resistance itself. When there is like certain factors are there which will affect the value of resistance. If you increase that certain parameter, your value of resistance will decrease or increase. So let's find out what are the factors. So first one is length of a conductor. Clear? R is directly proportional to L. It means that if you increase the value of R, sorry, if you increase the value of length, suppose that you have 1 meter wire, 1 meter of wire in a circuit. Now you have replaced that wire with a 2 meter wire. So what will happen? Your resistance will increase. Clear? Why? Because resistance depends on the length of the wire. Clear?
Yes, sir.
Everybody, is
Yes.
that clear? Okay. Next is area of cross section of wire. Area of cross section of wire. So what is area of cross section of wire? Just the area is the circular part, and the resistance is directly inversely proportional to that area. If you increase the area, your resistance will decrease or increase. Everybody, what do you say about the you can say the reciprocal, the inverse relation? If something is in inverse relation, what will happen if you increase the? Okay, now tell me, everybody. I have 1 by 2 and 1 by 4. Clear? Which which denominator is greater, 4 or 2?
2.
2 is greater than 4.
4 is greater, but 1 by 2 is greater.
I'm asking the denominator part only, not the fraction.
4 is greater.
4 is greater. So which, now tell me, everybody, if the 4 is greater, you are dividing 1 by a greater number, the fraction will decrease or increase?
Decrease.
Obviously. If you have same part and you're dividing it with a smaller number, your fraction will be greater than 1 by 4, or it will be less than 1 by 4?
Greater than.
Greater than 1 by 4, obviously. because this is a smaller numerical value than 4, so it will basically, okay, so now suppose that you have there are 4 siblings. In this part there are 4 siblings, so every sibling got 25% of the cake, suppose that thing. And in one family only 2 siblings are there, so they will get 50% of the cake. So which one is greater, 50 or 25?
50.
Obviously 50
50.
greater, eh? So that how now got it my point or not?
Yes.
So
So if you increase the denominator, ultimately your fraction will decrease. Clear? Now everybody, if you increase the denominator, if you increase the value of A, your resistance will decrease or increase.
increase.
Decrease.
Okay. Okay. What about like one, like think a little bit. Okay, so your fraction will decrease, na? If you're increasing the denominator, so your fraction is basically becoming smaller. So it's basically nothing but the value of R. It will decrease. So if you increase the value of denominator, your value of resistance will decrease. And if you decrease the value of resistance, your value will increase. Clear? Clear?
Yes, sir.
Yes, sir.
Okay. The third is nature of material. So basically, nature of material is that like everybody, like you can say every material has different resistance. If suppose that you are taking a wood and you are taking one copper wire, so resistance, it will affect the value, like these parameters will affect the value of the material, because if you one is wood and another one is, am I audible everybody?
Yes, sir.
So everybody, why is everybody so silent in this class? Like I'm not getting any response, like just I'm speaking and speaking again and again. Like is it not clear to you? To then let me know at least. Then remain, like be silent is not the solution of this thing. If you're getting, if you at least say yes, only one student is saying yes. That doesn't mean, like there are 6 students in the class itself right now. Like Shweta, Samina, Hiba, Afra, and Abdullah, and Karishma as well. So if I'm speaking, at least let me know that it's completely clear. If anybody is having any problem, please convey it to me that, sir, it's not getting, like I'm not getting a point or anything.
Yes, sir.
Yes, like that's my case. Like I've also said this in my maths class as well. If anybody is not getting my point, at least say it to me. I will, like, this will not affect my performance. It will affect yours. You are responsible for your own performance because you are not basically conveying it to me that, sir, I'm not getting your point. It will not affect mine. Definitely not. Why? Because I'm the one, I'm basically teaching you, but you are saying yes. So that's, you are basically telling lie to yourself that yes, sir, I'm getting, but even in the reality, you are not getting my point. If you are not, at least say it to me. I will explain it again. That will definitely like not going to help you if you are not, if you remain silent in the class with and they're just passing the time here. Definitely not going to help you. These words will be a little bit harsh for you, but that is the truth. You can hear these words by every teacher, because that's the fact. If the student is not responding in the class, so your teacher will lose the interest in you, and that's not a good thing, and that will affect your performance. Definitely affect your performance. Clear, everybody? So please be interactive in the class. I hope I'm not, that's why I'm not able to switch on my camera. Otherwise, I've taken all the classes like while switch on, opening my camera for the whole class. That inshallah, in the next class or in the Monday's class, I will be switching on my camera because I'm a little bit better now. But it's still, please try to cooperate with me, that if you are getting my point, at least say it to me so that I can think that yes, everybody is getting my point completely. Clear? Yeah, very good.
Yes, sir.
Okay. So nature of the material in that sense, suppose that you have one wood in a material and one is copper. So copper is a metal, wood is a non-metal. So which one will have higher resistance, wood or copper?
Copper. Copper.
Copper. Okay. What about wood? Anybody? I'm asking which one will have higher resistance. So are you able to conduct the electricity through wood? Is it possible to flow the electrons through wood?
No,
No,
sir.
no. I'm asking higher resistance. Higher resistance will, like, wood has much more higher resistance than copper, because wood is an insulator. I've taken this part in the starting of the class. I've told you that wood, like insulator, and difference between insulator and conductors. So wood has wood is an insulator, so it will have a higher resistance. Clear?
Yes, sir.
Clear, everybody? Very good. So it means that if you change the material, the resistance will also affect. Clear?
Yes.
Okay, everybody. So if you change the basically some, or you can say, if you take the silver wire and one is copper. So what is current? Everybody knows that the flow of electrons.
Yes, sir.
Yes or no? So flow of electrons is current basically in unit time. So now basically, how many of you heard the word valency and valence electron?
Yes, sir.
Okay. So basically, if the metal has very you can say like some of the metals are very easily loses electrons, just like the silver and all the thing, they easily lose their electrons. So silver has silver has low resistance because they easily lose their electrons, but copper a little bit lower you can say higher resistance comparison to silver. So that's why they're not able to lose their electrons in a, you can say, like fastly. But it's a good, you can say, in comparison to the resistance, it's a low resistance metal. So that affects the value of the resistance if you take some different materials. Clear?
Okay.
Yeah. So okay, let me write it the words here. The electrical resistance depends on the nature. of which it is made. Some materials have flow. Some have high. Clear? Next is the fourth one, which is temperature. I've told this part in the Ohm's law, then I've given you the overview of that part in the, you can say, the Ohm's law. So temperature is a quantity which affects the resistance. You can say like this. R is directly proportional to the temperature. Your temperature, the resistance becomes basically is directly proportional to the temperature. If you increase the value of temperature, the resistance will increase. It's for pure metals. Right now we are taking only the pure metals. We are not taking any superconductor or anything. Clear?
Okay.
Yes.
Okay, everybody?
Yes.
Okay. So basically, let me write the word here. The resistance of all pure metals increases on increasing the temperature and decreases on decreasing the temperature. Clear? Clear, everybody? Is that clear now?
Yes, sir.
Yeah. So,
Yes, sir.
okay, very good. Okay. So, now let's come to the part here when we merge these things. Okay. Okay, everybody. So when we merge these things, basically now current, basically on the left hand side, resistance is there. Same here in this case as well. On the left hand side, resistance is also there. So if you merge the both equations, this R is proportional to L and R is inversely proportional to 1 by A. So what will happen is that I will write the definition once here. So it will be like this. Yes or no, everybody? Yes or no?
Yes.
L
Yes.
by A. Clear? And if I remove this proportional sign, one constant will be introduced, which is the called as resistivity of the substance. So resistivity of the substance, you can say is that, so suppose that thing, suppose that thing, you have a bank account. How everybody have the, everybody has one bank account. Okay. So in India, I'm taking suppose in India, 2000 rupees is the default value which should be there in your account. Below that, it's not possible to maintain this. Suppose that this is not possible to withdraw this 2000, or your balance cannot go below the 2000 rupees. Clear? So this is a specific value, or you can say the default value of the bank account. Yes or no?
Yes, sir.
Clear? So This is called the same here. Every substance, every material, every metal has the specific resistance. It means that if you have 1 meter of wire of that substance, that wire will give you how much resistance? The specific resistance, basically. That specific resistance is called resistivity. The default resistance of a wire, you can say default now, because it's the wire, you can say the resistance, it cannot below that point. That value is called resistivity. Or let me take one more example. Okay. Let me take one more example. Suppose that thing, you have mobiles, everybody have mobiles. So your balance cannot go beyond zero, below zero, in the negative. Yes or no, everybody?
Yes, sir.
It means that you will definitely have that zero balance in your account. Your balance cannot be negative. It can be positive, but it cannot be negative. It will, the lowest will be zero. And the validity is for lifetime, I think so. Clear? And same thing, if you take one wire of this any metal, it means that suppose that it's copper wire. Copper wire is there. If you take that copper wire, this copper 1 meter and its value is 1 meter, this will give you a certain resistance. Clear? This will give you a certain resistance. That resistance will be called as specific resistance. You can, sorry, resistivity. This every 1 meter of copper wire will give you same resistance. That resistance is called the specific resistance. The default value of any material is called as the resistivity. I think it's clear. Yes or no, everybody, at least yes or no? If it's
Yes,
clear,
sir.
yes or no?
Yes.
Or you can say in human body, number of blood counts are there. A default value, like it should be around this and this. Somewhat like it can go
Yes.
above that value, but it should not go beyond that value. Suppose that thing that it will not, assume that in that case, the blood counts will not go from the minimum value. Clear? So it will be around, suppose that 1000. I'm just taking 1000. So 1000 will be your, every human body will have definitely the count of 1000 blood counts. Yes or no?
Yes.
Yes, sir.
Yes. Yeah. So okay. So every material which give you a specific, a default value of the resistance is that value of resistance is called as resistivity. Specific resistance. Specific word is used now. Specific means like if you are taking the copper wire of 1 meter, that copper wire will have definite, or you can say specific resistance value. And if you're taking silver wire, that silver wire will have specific definite value. That value is called as the resistivity. Okay.
Okay.
And if you take the formula, so resistivity will be R by L. Just multiply this A into here and divide it by L. And the SI unit of resistivity is ohm meter. Ohm meter. Put the value of resistance here. It's ohm. Area is m square divided by m. M will cancel this. So ohm meter is left now. Yes or no?
Yes, sir. Yes, sir.
That's how you will find out the SI unit of this. Is that clear, everybody? Yes or no? Please let me know.
Yes, sir.
Yes, sir. Clear. Yes, sir.
Okay, just a second. Afra, Hiba, Karishma, Samina, Shweta, 1, 2, 3, 4, 5, 6. Okay, okay. No issues. So one more thing is that resistivity, basically, resistivity does not depend on the length, does not depend on the area of the cross section. It means that if you suppose that you have 1 meter of copper wire, and if you increase the value of the area of cross section, The resistivity will same for that 1 meter of wire. I'm saying resistivity. Everybody got it on note?
Yes, sir.
Definite resistance and resistivity are different values. Resistance will become equals to resistivity when the length of the conductor will be 1 meter and the area will be 1 meter square. Clear? The resistance will become equals to resistivity. Clear? Resistivity will not change of a substance if you increase the length or the cross-section area, or you decrease the length of cross-section area. It will change when you change the material, because like right now it's almost the end of the class. That's why I'm not writing on the screen. I'm just telling you what are the effects of resistivity, of the factors affecting the resistivity. So it will not be affected by the length and area of cross section of the material. Oh, sorry, area of cross. If you increase the or decrease the area of cross section of that material. Resistivity. Clear, everybody? Resistivity is the default value. Clear?
Yes, sir. Yes, sir.
We choose the metals, or the, you can say, the conductors based on the resistivity, not on the resistance, because we can increase or decrease the resistance on our own, but resistivity will remain same. It will not change if you increase the if you increase the length or decrease the length, or you increase the area of cross section or decrease the area of cross section. It will remain same as it is. Clear, everybody?
Yes, sir.
I hope it's clear now.
Yes, sir.
Any doubt till now?
No, sir.
No, sir.
Sure.
Yes, sir.
Yes, sir.
Okay. Okay, sorry for the, like, I was a little bit rough on you. Sorry for that, but dear, that's for the benefit of yours. I'm not like, I know, like, the performance will not be affected of mine. It will be yours, because if you don't say it to me that it's not clear or anything, if you're not clear to me, so how would I know that that you are getting my point? You have to tell. Now, if you are going to the doctor, you have to tell you on your own that doctor, like, I'm getting, like, I'm having fever, I'm getting cough and cold, like, here is the pain in my body. Yes or no? Then doctor will check and then it will give you the prescription. Yes or no? Unless and until, if you're not telling it to me, if you're not clear, not honest with me that you are getting or not, how would I know that you are getting my point and you are completely understanding my terms? Clear? So it's very important to be honest and to be clear with the teachers as well. Clear? And that will definitely benefit you if you are like completely clear with the teacher. I'm not saying specific to me. Every teacher, if you are clear with any of the teacher, you will get definitely the concept. If you are not getting the point of that teacher, just say it to the teacher. Whether it's like, it's just like, I'm not saying only